All right, all you cool cats and kittens, the last section of chapter one in the book is going to be our last video, and this is where we talk about our elements. So, obviously, take a look at our bestie periodic table. When you look at the periodic table, you can already see some patterns, all right? You can start to notice that there's different types of elements in different locations. You can see the states of matter in different parts as well. And what we're going to do is really look down here at this section of the elements and how they're split up into metals, nonmetals, metalloids, and noble gases. Okay, so chemistry is the study of the composition of matter and the changes that they undergo. They can be either pure substances or mixtures. Um, the elements or compounds, elements being the most fundamental building blocks, like letters of the alphabets, compounds being more like words. So these elements are broken up into metals, nonmetals, metalloids, noble gases. So I guess our elements could be broken up, if we follow the analogy, closer into like consonants and vowels. All right, and that's what our different sections are here. All right, so when we take a look at our periodic table, the typical metals that you would think of, like when I say, all right, name me a metal. What do you say? Aluminum, and you say zinc, and you say silver, or gold, or copper, or mercury, or chromium, or titanium, or tin, or lead. Those typical elements that you would think of being metallic are all going to be on the left side of the periodic table. These are where our metals are going to be. When I say name me a gas. Okay, name me a non-metal. You're going to be like, oh, well, we breathe in oxygen and we breathe in nitrogen, and there's chlorine and there's some iodine. Well, these are all going to be on the right side of the periodic table. And it's not left and right straight down the middle. It's going to be over our line of demarcation, which we'll talk about in a little bit also, and making it left and right. And the right side are going to be your non-metals. Okay, and hydrogen is technically a nonmetal. We'll talk about why he's over there. Um, and what you'll see is that our periodic table is broken up into um, 18 different columns. Those are our vertical columns and groups. There are families. And just like we have something in common with our families, the same thing is true for our elements. Okay? Our periods or rows, there are going to be 7 of them. Okay, and in class we'll go through and play the updated periodic table song for you. So one of the things that I want to point out is if we take a look at this over here, you'll see that we have our 1, 2, 3, 4, 5, blah, 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 13, 14, 15, 16, 18 groups. And then our rows, this is row 1, this is row 2, 3, 4, 5, 6, and 7 going across the periodic table. But Miss Lynn, what about those two down at the bottom? Well, you see, this is the lanthanide series, and the lanthanide series starts with number 57. That gets inserted here, and it goes to number 71 over here, and then 72 starts over here. So lanthanide is actually part of row 6, and the actinide series is 89 to 103. This goes up here and is actually part of row 7. But Ms. Lynn, it looks like 9 rows. Yeah, I understand it looks like 9 rows, but it's really not. And the reason why that they're down here is because our families, our groups, have similar properties. So titanium, zirconium, hafnium, and all the way down to rutherfordium all have the same property. If we put 57 through 71 in here, these guys would be moved over here. So they're kind of written as a footnote, especially because these guys are less common and ones that we don't use as much. So In class, I actually show you the difference between how the periodic table should look. So it basically has this cutout, and then this section is separated so that your families still stay the same. Okay, so those are common questions that we get. All right, so the line of demarcation is that jagged stairs. It denotes the difference between the left and the right side on the periodic table. And you'll see that it is basically over here on the right-hand side. So this whole left and middle section are going to be your metals. This right section is going to be your nonmetals. And anything that touches that line of demarcation is kind of too close to call. So it's going to be a metalloid. It's going to have properties of both. So what is a metal? Okay, a metal is going to be all of those elements over here on the left side, and they all have similar properties. So does that mean that hydrogen is a metal? Well, yeah, technically. Okay, it's going to donate protons. It's going to have a positive charge, or sorry, donate electrons, and it's going to have a positive charge, and it's going to do things more similar to the way iron does than the way that oxygen does. So this is our line of demarcation right here, and that's what splits up our periodic table into two parts. Okay, so when I say left and right, I mean left and right of the line. So you'll see that you have this nice bolded part in here. All right, so the right side is going to be our nonmetals, where all of our gases are going to be, and one of our liquids, mercury, is a little outlier over here. And again, you'll see our lanthanide and actinide series in column or rows 6 and 7 that go right here and right there. All right, so a property of a metal is going to be that they conduct heat and electricity, which means that they're going to be really compact. That's why we use those different types of copper wires. They're malleable. They can be made into all different kinds of shapes. They're relatively strong and have relatively high melting and freezing points. Most are solids. Yes, we have our hydrogen and our mercury, but the majority of them are all solids, and they have luster, which, if you like Moana, means that they are shiny. All right, and then our nonmetals are going to be the opposite. They're not conductors of heat and electricity, they insulate. They do not conduct well. That's why you'll see, like on a hammer, here's my really bad drawing of a claw hammer. All right, the whole handle will be made out of an insulator, whereas the strong part will be made out of the metal, where if you happen to hit something, it will insulate so that you don't get shocked. All right, they are brittle, relatively speaking. They have low melting points and freezing points. This is where our gases and our liquid bromine is going to be, and they're dull. They are not going to be as shiny as your metallic substances. All right, so what are our metalloids? Our metalloids are going to be those substances along the demarcation line. Okay, so it's going to be boron, silicon, and germanium. So the line goes this way, right here. Arsenic and antimony, tellurium, and polonium. All right, boron is lumped in there, but the one that is not lumped in there is aluminum. Aluminum is a metal. It's a weird metal, and we'll get into the difference between aluminium, and tin and all that kind of stuff, and how they are so different um, from our typical metals. But you'll see that the metalloids are going to be these 1, 2, 3, 4, 5, 6, 7 elements right here. They contain properties of both. They are on the fence. Okay, silicon, okay, is a semiconductor. It is going to conduct an electrical current but not overheat. So in, SIM cards and CPUs and stuff like that, you're going to see that it will conduct electricity but not overheat. The downside is they are brittle. So if you drop it enough, yeah, your SIM cards can break and those wafers can break, and that would be really bad. All right, and then lastly, we have our group 18 noble gases. They are all gases at room temperature, and the reason why they are called noble gases is that they don't react or combine with any other element. So, like the nobility and commoners way back in the day, the nobles didn't interact with the commoners. So, therefore, yeah, they were fine by themselves. The same thing is true for our noble gases. They are full of electrons, and their desire to react with things is not natural. We can force things to happen with a lot of energy, but in nature it does not. So you'll see, like in a balloon that's filled with helium. In signs, you'll have neon, really important historical artifacts and pieces of art are in between panes of glass and sealed with argon gas so that the nitrogen and the oxygen won't make the paper disappear. Anybody know what this picture is over here? This is the Hindenburg. This is the Nazi blimp that they used hydrogen instead of helium. Helium on the periodic table is all the way over here with the noble gases. Hydrogen is over here. Well, the Nazis, which are really bad people, had an embargo placed upon them and nobody was trading helium with them. And they were like, yeah, well, hydrogen does the same thing. Oh, yeah? Not. Hydrogen is going to be very explosive. So the Nazi fleet all exploded. Okay, we don't want to use hydrogen here because if we used hydrogen here in a balloon, if somebody accidentally bumped your birthday balloons close to your cake, kablooey, there would be cake everywhere, and that would not be good to have that kind of fireball. All right, so these noble gases don't react. They are very docile. They are inert, and that means that they don't react the other way things do. And we'll talk a lot more about these as we go through the course. So, thank you for this viewing of the introduction of chemistry, and I hope you like all of my videos. Take care.